So, we're starting to talk about scientific notation. Whoops, let's get this on first. In scientific notation, we've seen in our bell work. And the reason we use scientific notation is for when you have really, really big numbers and really, really small numbers, right? So, numbers so big or so small that they don't even fit in your calculator. Your calculator can hold 9 spaces, right? There have been kids who've come up to me before and showed me their screen and said, something's wrong with my calculator because it has an e to the negative something, right? It's because you put in a problem that the answer is way too big for it to handle, okay? So, when we talk about, let's go ahead and write this, Unit 6, Learning Target 6, Scientific Notation, okay? And that's when you use extremely large or extremely small numbers. Okay? I'm not sure this is the exact reason why, but the only thing I can think of is that they call it scientific notation because it's really science that you would use numbers this quantity, right? You know, I guess I equate it to, I don't know what year it is that you study Pangea, right? The supercontinent. Before there were 7 continents, there was one big continent, right? You had to paste them all together, okay? Okay, well, over the course of millions of years, each continent drifted. And it drifted 0.000000000012 centimeters a year. I just totally made that up. That's not right. But it's not like the continent moved and everybody went, whoa, what did that happen? You know, it was a very gradual movement, right? So that is such a small number, it's so hard for us to comprehend, correct? Okay. On the other end of it, think about like outer space and, you know, the Milky Way and that galaxy and how far away it is from us. We may need scientific notation to talk about the number of miles. It might be more than 1 billion miles away. It might be, if you think about inches, think about how many inches it is away. That's a huge number that you would need. Yeah, okay? So we're going to talk about scientific notation, and that's, my guess, is why they call it that. Is because those science concepts are what we deal with. So we use base 10 in scientific notation because base 10 is easy to deal with, right? Okay, there's a couple things that I want to review before we even get into talking about that. Not sure what grade it is, maybe 3rd or 4th, but multiplying and dividing by powers of 10 is something that you learned, right? So like if I have 4.5 and I want to multiply it by 10, multiplying means you're making a number bigger, and the shortcut is that you move the decimal 1 to the right, right? So if you're thinking of money, $4.50 became $45, right? So that turned it into a bigger number, in which operation makes things bigger, multiplication, right? So when you multiply by a power of 10, the decimal gets moved to the right, correct? Okay? What if I took that $4.50 and needed to split it into 10 piles instead of create 10 piles? Okay? That meant that you're making it smaller, and then that 45 cents became, or I'm sorry, that $4.50 became 45 cents, right? Which made it smaller. So division moves your decimal to the left. I didn't want to put an arrow going to the right. Okay, do you remember that? And here's the other thing. If you multiplied that $4.50 by 100, then don't move the decimal once, move it twice. Multiply it by 1,000 and move that decimal 3 times. So you remember that, right? Okay? So whenever you hear a teacher say, move the decimal 3 times, that is a very lazy way of saying multiply by 1,000, okay? So you may hear me say that, catch me, or, you know, if it's strictly moving. So if I'm going to have you move stuff today, I might say multiply by 1,000. But to make it easier for you to understand it first, I'll say go ahead and move it 3 times to the right. Dividing by 1,000 would be moving it 3 times to the left, okay? So now that we got that out of the way, this is an example of a number that is written in scientific notation, okay? here are all the qualifications for a number to be in scientific notation. You can only have one number in front of the decimal, meaning you can have a ones place and nothing else, okay? Can only have one number in front, okay? The other qualification is that all other, we're gonna call these non-zero numbers, okay? You can grab a calculator if you need it. All other non-zero numbers are after. There may be some non-zeros, there may not. And then the other thing is that there's always going to be a base 10. Oh, and then the other thing, it's kind of important, it's always multiplication. Okay? Those four things qualify that to be considered standard or scientific notation. Okay? So let's start out with something that's not in scientific notation. No, let's not do that one yet. I'm going to do this one first. Okay. So there's two forms. You have scientific. Is the announcement going to come on? You guys don't have to leave. They'll announce it. And then standard. Okay? So scientific means it's written like this. Standard means none of that. It's just the plain old number. What number is it? Okay? So let's take this 4.259 times 10 to the 7th and turn it into standard form. Meaning, if I had a calculator big enough to do this math, what would this number actually be and look like? Okay? So what that means is, yeah.
I have a question.
Yes.
Bigger calculators, can they hold more numbers?
Yeah, it's, you know what? They probably could. It would be the person who programmed that calculator. The people who at TI, Texas Instruments, decided that they only wanted it to go 9 places. I'm sure there's a coding that somebody would do that allows more spaces for that, but ours don't, and most don't really. Okay, so here we go. 10 to the 7th is the same as, and you're not going to write this, a 1 with 7 zeros. I mean, you can write it for your notes, but you're not going to write this in your... So 1, 2, 3. 1, 2, 3. That's 10 million. So basically what I'm saying is I have 4.259 and I want 10 million piles of it. How much would I have total? So you learned in 4th grade, but I just reminded you a couple minutes ago about what it means when you multiply by that, right? It means move it 1 to the right for every 0 there is. And how many zeros are there? 7. So I'm going to take this decimal and move it 7 places to the right. Now, watch what happens after I move it 3 places. I run out of room. So if I've already moved it 3, I need to move it a total of 7. I need to add some zeros. How many? Yes, right? That's it. So first thing you're going to do is write your 4.259. All of your non-zero numbers get written. And then I'm going to add those 4 zeros. But I'm not done because I need to put those commas in. Start from the back and they go every 3. You know that? Did you guys see that YouTube video of that little boy he was on that Steve Harvey show?
No, you should show it to us.
I will. I will at some point. I don't have any time right now, but there was a number that had like 30 digits in it, and he said 542 quintillion, 649 quadrillion, 342 trillion, 700. I mean, it was like 15. It was like 20 digits, and this little 3. Like I don't know how old he was, but it was ridiculous. Okay, so a lot of the other hours saw it. So just search up like kids saying really big number, and you'll see it. So real quick, hold on. So is everybody okay with how we got that answer?
Yeah.
That number will not fit in the calculator. It's 42,590,000. Okay. So here's what I did. I saw that the exponent was positive. Positive means a very big number, so I moved it to the right. Got it? Let's take a look at our next example. Let's take this 4.259 and multiply it by 10 to the negative 7th power instead of positive 7th power. Okay? So if you were, well, actually, we'll do it the short way first. So what this means is I'm going to take this, and because it's negative, this is the same as 4.259 times 1 over 10 to the positive 7th. We just learned that, right? That's why I taught you negative exponents before I taught you this. Because what this really means is 4.259 over 1 times 1 over 1 with, okay, which is going to give me this, which is going to give me, that's a teeny tiny number, isn't it? So which direction do I need to move this decimal to make this number teeny? To the left, correct? So I need to move it 7 spaces to the left from where it is, and I move it 1 and then run out. So how many zeros will I need to add? 6. So this answer is going to be, put your decimal, 1, 2, 3, 4, 5, 6, and then all the other non-zero numbers. Got it? So I'm going to give you a minute to have that settle in and see if that makes sense. So when it was positive, I moved it to the right. And when it was negative, I moved it to the left, because this is really the same as that, and that's a small number just like that is a small number. Did you follow that? Okay. All right. So let's take a look. Then you try these two. Ready? 3.16 times 10 to the 5th. Write that in standard form. What number is that really? And when you're done, try this one. Whoops, not negative. We're not ready for that yet. Yeah. Never mind. Okay. So go ahead and try those two. Okay. You're looking at this problem, and that itty-bitty exponent is the boss of everything. It tells you two things, and here's really what it comes down to, guys. You need to know how many places am I going to move it, and in what direction am I going to move it, right? This is the same as 100,000. It's got 5 zeros. So I'm going to take this, and because it's positive, move it 5 to the right. So this is going to be moved 2 places before I run out. Add 3 more zeros. Go ahead.
Can you now release an 8th grade girls softball team and an 8th grade boys baseball?
So those of you who are watching video notes, pick up at about 13-minute mark. Okay, good luck.
You know, there's a quarterback that is going, I think he's going to Tennessee. You can recite pi to the 74.
That's crazy. Okay? Okay, ready? Shh, did you hear me? 13-minute mark on the notes is where you'll pick up. Okay, so did everybody get that? Good luck. So then, basically, I mean, that's not a huge number. It's 316,000, right? Okay, did you do this one? So this is going to be moved 8 places to the left, right? Why to the left? Because it's negative. And negative is really, really small. So I move it 1 place, then run out of places. So I'm going to add how many? 7. So 1. Don't forget your 0 in front. 2, 3, 4, 5, 6, 7, and then the 42906. If 0 is kind of sandwiched in the middle there, it goes until the end is a non-zero number. So is that what you got? Yeah. So these problems are kind of pretty much a pain in the butt for me to check, because the only way for me to check them is to go, oh my gosh, 1, 2, 3, 4, 5, 6, 7. Do they have 7 zeros? I have to count them. Okay? Are you good with that so far? Okay. So now we're going to talk about going the other direction. Meaning, I'm going to give you either a giant number written in standard form or a teeny number, and you are going to make it go to scientific. Okay? So we kind of got to reverse our thinking here. So are you ready for this? So let's take the number 329, comma 400,000. Okay? And I want to know what is a fancy way to write that number in scientific notation. So let's not overthink this. People started to get confused on this last hour. Where is the decimal right now? At the end, right? It's hiding. You can't see it, but it's there. Where do I need the decimal to be? After the 3. I need it to be, what did I say? There has to be one number in front. So if you need to do this to kind of help you, that means only one number can go there, then all of the other non-zero numbers have to go after it. So you know what you could write? 3.294 times 10. Maddie.
What if it was like 30, no.
If there was a 0 in there between,
No, I mean like, what if it was like 32.94?
then it would be a really small number. We'll do that one next. Okay? So, step 1, get all these non-zero numbers like this, put your times 10, and then wait. Okay? Because the final part of this problem is figuring out the exponent. All right? So, the question is, how many times or how many places do I need to move that until it gets to where I need it to be? 1, 2, 3, 4, 5, 6, 7, 8. So look at, that's an 8. Okay, I'm not done yet, because then I have to ask myself, is that a positive or a negative 8? Well, what did I say? Didn't I say that the positive exponents give you really big numbers and the negative exponents give you really small? Is that a really big number? So that exponent needs to be positive. Did you see how I just got that? Okay. Take this one. 4, 3, point 0, comma 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay. So I want that written. Yeah.
So you have to count all the numbers, not just the zeros?
Well, you have to count places, not necessarily numbers. You need to count how many places it takes you until it gets to where you need it to be. And you always need it to be one number and then a decimal. Okay? There can never be more than one number in front of the decimal. So right now, I know that I want that to be 4.3 times 10 to a certain power. I just got to figure out what power to get it to. So where is the decimal? Okay, Olivia and Maddie, please pay attention. Okay, so the decimal is right here. How many places do I need to move it until it's where I need it? 3, 6, 9, 10. Done. Okay, and it's positive because that number is a big number. Okay, ready? Maddie asked for this one earlier. So if I have something like this, I'll get to that problem, but 0.0000593. I need that number written in scientific notation. So I always start by setting it up. Where do I want the decimal to be? I want it to be after the 5. All of your other non-zero numbers go with it. Times 10, and now I got to figure out the exponent, right? Mm-hmm. Go ahead. Very good. You hear what he said? So he's even ahead of me. Look, I said 1, 2, 3, 4, 5, 6, and then stop for a second. That's not a giant number. That's a teeny number. And teeny numbers have negative exponent, right? Okay? And here's why that is what it is. Because 10 to the 6th is really 1 over 10 to the positive 6th, which is 1 over 1 million. It's 1 millionth. That's fine. So that's why that is so small. And that's why that's negative. Understand? Okay? Let's do another one. I want you to try this right here. 0.00029. Just keep it simple. Write that number in scientific notation. So Kylie, when you start the notes, if you can't catch up, you'll start. Well, you'll need to start for the whole thing. Yeah, never mind. Okay. So I know I need it to look like that, right? I need that decimal in between the 2 and the 9. You can only have one number in front. I'm looking at here. It needs to be here. I move it 1, 2, 3, 4, 5. So that is a -5. It's negative because that's a tiny number. Is that what you got? Okay. So what if I asked you to do, now let's go back to this problem right here. Let's take 6. Now we're going to go back the other way. I'm going to give you scientific notation and ask you to put it in standard form. This one's a little trickier because there is no decimal. You know, all the other problems I gave you were, 4.259, 3.16, 3.294. Well, now I'm just giving you 6. So what? You already know what you're doing. You're doing it already, right? The decimal's there. They just don't have to show it. So, Kylie, what we learned is that this exponent tells us what direction and how many. So it's going to tell me wherever the decimal is, take it and move it 4 to the left from wherever it is. And right now it's here. So here's 1, and then I have to put how many more zeros? 3 more, right? Because I need to move it. Now here's what's so important. This does not tell you the number of zeros to put, right? It tells you the number of places to move it. So I'm only putting 3 zeros because I already had it moved one spot. 1, 2, 3, 4. That's my answer. Okay, see if you can follow me on this. Here's another way for you to do this. Pretty sure you don't want to do it this way. This is the same as taking and multiplying 6 by 1 over 10 to the positive 4th, right? We learned that. And that's 6 over 1 times 1 over 10,000, which is 6 over 10,000. And how do you say that? 6 10,000ths, right? How do you say that? 6 10,000ths. So do you see that you get the same answer? So if you could turn it positive, do this junk, pain in the butt. Don't do that. There's a shortcut. Negative, move it to the left. Got it? Okay. So now, there will be times, and we're almost done, there will be times where I'll give you a problem like this. 436.5 times 10 to the 7th. Okay? Okay? You're looking at that, and if I say put it in scientific notation, if you glance at it real quickly, you might say, it is. It is in scientific notation. The definition of scientific notation says you can only have one number in front of the decimal. How many does this one have? 3. So it might look like it is, but I know I need to do this. So watch. This is where you might get a little confused, but it's actually common sense. So I need it to be 4.365. All right? But I can't just keep that and bring that 7 down, right? You know that. You totally would change the problem. So let's think about this. I moved the decimal 2 to the left, which made it smaller. Right? So by making this number smaller, if I want to get the same answer, I better compensate and make this number bigger. If this gets smaller and I still want the same answer, I'm repeating it because it was that important. Because I moved it to the left, I turned 436 into 4.36. This gets smaller, then this exponent gets larger by 2. I move it 2 places, so that 7 becomes a 9. That's like saying I added 2 more zeros to make up for the fact that I just took 2 places off here, right? I'm going to do another one because I kind of feel like we're like kind of halfway there. 52 and 37. Yeah. And you know what? That would be okay if I asked you to put it into standard form. Do you guys know? I'm really glad she asked that. Because if I said put it in standard form, then you would take that and you would go 1, 2, 3, 4, 5, 6, 7. Boom, there's your answer, right? But if I asked you to put it in scientific notation, which is this, do you see the difference? Okay? If I ask you to put it in standard form from here, you don't have to move it and then do it again. You could do just what Kylie said, just move it. But I didn't ask you to do standard. I asked you to do scientific, okay? So take this, 10 to the 4th. So go ahead and try to see what you think that one would be. Make that into the correct scientific notation, meaning I need it to be 5.237. So you got to think about what would you turn that 4 into. You only got to make it change by 1 because I only moved this decimal by 1. But is it a 3 or a 5? Yes. You made it one smaller, so make this one bigger, okay? So common sense is going to tell me that now for this problem, 0.034 times 10 to the 5th, and I want you to write that in scientific, meaning fix it. Don't do standard. Don't tell me what that number really is. Put it into scientific. So I need it to be here, but I got to figure out what to do with that variable. I made it bigger by 2 places, so this needs to make up for it and go smaller by 2 places. So that 5 is really a 3, not a 7. Did you see that? So this got bigger, so that needs to get smaller if you want the same answer, and you do, right? Okay, I got one more thing to show you, because this is where it gets a little trickier or a little confusing. Are you ready? 4592.7 times 10 to the negative 11th. That negative. If I said put this in standard form, you would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Boom, and be done, right? You would move it 11 to the left. There were already 4 spaces. You would add 7 zeros and be done, right? But what if I asked you to put it in scientific notation? You might look at it and say, it already is. No, it's not. I need it to be 4.5927. So what did I do with that number? Did I make this number smaller or larger? I made it smaller by 3 places. So I need to make this one bigger by 3 places. And sometimes kids get a little confused. What's bigger than negative 11? 12 or 10? Picture yourself getting closer to 0, right? So what's 3 places bigger than negative 11? Got it? Okay, so when it's a negative, people start losing their minds and start messing things up. This got smaller, that's got to get bigger. Yeah.
Do you have to solve that problem?
It depends on what it asks you. If it might say, did everybody understand? Because it might just say put it in scientific. It might say put it in standard. If it asks for it in standard, you would go 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 4, 5, 9, 2, 7. And that would be it. This would be standard. This would be scientific. So it depends on, so you really have to read the directions. Okay, last one, I promise. Ready? 0.00015 times 10 to the negative 3rd. Go ahead and do what you think that answer should be. Put it in, I guess I need to specify, put it in scientific. Okay, you know it needs to be that. Every single time it's going to be one number in front, the others after, times a 10, and then now it's just all about the exponent. So I'm making it bigger because I'm going to the right? I'm making it bigger. 1, 2, 3, 4. So this needs to go for smaller, which is going to make that what? 7, right? 7, 7. And what if it would have had to been bigger? What's 4 bigger than -3? 1, right? Because you'd have to cross over 0. So keep that in mind. And then, how about this? Write this in scientific notation. 14. Write 14 in scientific notation. I don't need it to be in scientific notation. I just need you to know how to do it. So where's the 0? Where does it need to be? Write it. So the question is, be very careful here, because this is where people started to go, I moved it to the left. Why isn't it negative? Right? So this is actually going to be a positive 1, right? Which is the same as just 10, right? Because what is 1.4 times 10? 14, right? So just because you moved this, here's what I'm asking you. Is this a big number or a teeny decimal number? Big. Big means positive. Okay, this one is the trickiest one of them all. Write 8 in, what's so funny? Because I keep saying, and then I keep coming up with another one because, so 8 in scientific, I promise this is the last one.
I'll remember that.
Yes, scientific. It's Maddie that's keeping count, right? She's probably letting everybody else know. In scientific notation. Okay. This is almost kind of a trick question. Because where's the decimal? And it's right where it needs to be, right? So how many places do I need to move that decimal? But I need to write it in scientific notation still. No, it's not. Scientific notation has times a base 10. So, Kylie, what?
Do you put 10 to the 0?
Yes, you do. Think about it. 8 times 10 to the 0 power. It's not in scientific notation unless it has times a base 10. And what is 10 to the 0 power? 1. And what's 8 times 1? 8. Last one. Promise. Done. See? All right. Party har har.